Hello, this is Jason Chonko from SIGLENT Technologies. In today's video, we're going to look at the distance to fault feature for the SIGLENT SVA1000X series of spectrum and vector network analyzers. So in this particular video, we're just going to take a look at this feature. Distance to fault is a very nice feature for determining whether you have cable faults or you want to determine the length of a particular run of cable. It's actually quite good at determining where particular faults develop over time as the impedance changes between connections. Let's say you're using a barrel adapter or something like that, or some type of connector, and as it corrodes, it's going to change the impedance, and then that could cause signal issues later on. So the distance to fault can help you troubleshoot that particular line and determine where those faults might be. Maybe the insulation has worn away and you're losing some of the conductivity on that cable due to corrosion again, or you have a break in the actual cable. The distance to fault feature uses Frequency Domain Reflectometry. That's also known as FDR. FDR sends a series of frequencies out of the tracking generator port. Then it's measuring the reflections back into that tracking generator port and collecting data, performing some calculations on that reflected information or reflected signal, and then determining where those impedance differences are based on those swept frequencies. Another technique is time domain reflectometry. Frequency domain reflectometry has some advantages in its position accuracy. It does have some limitations as far as the length, but if you're looking at cables around 100 or 200 feet, this is going to get you within a few inches of that fault. So that is a really, really nice place to start when you go hunting for a few hundred feet of cable for that problem. So what I'm going to do today to show you this feature, I just have I've got three RG58 BNC cables, and I'm just going to connect them together with barrel adapters. And these are slightly different in length. So the first one that I'm going to connect, I believe, is going to be my 3-footer. Let's take a look here. Just a second. Yep, I'm going to connect up my 3-footer. Oh, actually, we're going to put this into distance to fault mode. Pressing mode, we're going to press distance to fault. This comes as a trial option on every SVA. You get over 100 hours of the feature, and if you would like to permanently activate it, you just from your local SIGLENT distributor or your SIGLENT office, order the license key, enter that, and you'll be all set. Here we've got the display. We're just showing the amplitude return versus the distance out. Here you can see we can change the start and stop distance. Since I know this is only going to be about 10 feet of total cable length, I'm going to set my stop distance to 20 feet. I want to look at units of feet. My velocity factor is 0.66. You want to key that in for the specific cable type that you have if you know it. 0.66 is fairly common, but if more accuracy is going to be achieved if you enter the correct values for your specific cable type. We've got cable attenuation, and then the different windowing features. So I'm just going to set, again, I'm going to connect up this 3-foot cable, which is open termination. And you'll see my peak distance is reading at 2.97. I'm actually going to move the marker number 1 over to that peak. And there we go. Yep, 3 feet exactly. So you can see this largest peak is that first reflected value. If I take this end and I terminate it with 50 ohms, you'll see things clean up considerably. But with that opening, we're getting a lot of reflections, and so we're going to see a few different types of peaks. Now I'm going to take a barrel adapter and I'm going to connect another cable. This cable length is actually 4.5 or 3.54 feet, 42.5 inches. I'm going to connect that up. Now we'll see the two distances. So now I'm seeing that first peak, which is my first cable at 3 feet, and then my second is at 6.84. I'm just going to change number 2 and go to that peak, and that's at 6.65 feet, or 6.58 feet. All right, so that's 6.58. Now I'm going to connect another chunk of cable here, and we'll be able to now see the third peak. And we'll just go to that normal, and you'll see now we've added 9.86 feet. So now we have our total. All three of these peaks represent each of the cable adapter connections, basically measuring to that center line on that barrel adapter. and then they're all laid out for us. If you happen to see quite a bit of noise on the signal, we can actually do some averaging as well. We can go to trace and turn on averaging, and that will actually quiet it a little bit. You'll see the average count come up. And so now we're able to measure all of those distances to each of those different impedances. So remember, these are 50 ohm barrel adapters, but they aren't perfect. And so we're still seeing, just because of that minimum impedance difference, we're actually seeing those changes. Now if I terminate in that 50 ohm termination again, you'll see we're going to decrease a lot of the excess peaks and noise. So we're actually getting rid of the excess peaks and the calculations on the other end. So really our cable does terminate there. So using the distance default feature, very simple. We can see each one of those connection points, and we could actually take a picture of this if we wanted to. We could insert a USB stick and save this picture exactly as it stands, or we could save it to memory and compare it later. So as the connections may degrade over time, we can compare that to we can compare the new picture to this existing picture. So as your cables age, you can start to compare the different, is it corroding in certain areas? I have had some customers report that they've had lightning suppression elements on their cable start to wear through the dielectric, and they can see that using the distance default feature. So again, they can check out where that exact break is or where the problem is before they even get up on a ladder or climb the tower.